Hey, how's it going, guys? I hope that this video finds you well as always. In this video, we are going to be talking about sex-linked traits. These are going to be traits that will be passed on from parents to offspring via the X and the Y chromosomes. So they're going to be found in the sex chromosomes. Now, these are two pictures here, or a picture of the Y chromosome, the smaller one, and the X chromosome. And you see these darker bands here that actually represent those chromosomes, alleles, which can contain those traits that will be passed on from the parent to the offspring. All right. Now, the objective for today is going to be to predict possible outcomes of various genetic crosses, including sex-linked crosses. Make sure that you write down an essential question on your paper, and the essential question that I have written for you here is, how do I use a Punnett squares to predict outcomes of sex-linked crosses? So we're still going to be using those Punnett squares that we've learned how to use, and we are actually going to be using them to predict sex-linked traits. All right. So just a little warm up to get started. I want you to try to figure this out. It's very, very simple. It says to complete a Punnett square for the cross between a human female, X and X, and a human male, X and Y. So what are the chances that the parents will have a girl? So to do this is very simple, because you know that one of the parents is going to go on the top like this, so that's the mother, and then the father will go on the side, the X and the Y will go here. And so what you do is you want to match them, right? We've been doing this for a little bit now, so you should be able to do this. X and X, X and X, and now you have the X and the Y, and the X and the Y. So really there is a 50% chance, or 2 squares out of the total of 4, 50% chance of having a female, versus the other 50% chance, or again 2 out of 4, of having a male. And this is how it's going to work every single time. You're going to have a 50% chance of having a girl and a 50% chance of having a boy. Now remember, these are just probabilities, right? Punnett square is a prediction. So, you have always heard about those families where there are 7 girls and no boys, or 6 boys and no girls. But again, the chances are still the same. You have a 50-50 chance of having a girl versus having a boy. Now, sex-linked inheritance is the traits that will be passed on from parents to offspring again, but this time they're going to be passed on in the X and the Y chromosomes. So we talked about karyotyping before, right? We talked about the picture of these chromosomes, and remember that humans have 46 total chromosomes inside of our cells. Each of the cells have all 46 of them. Now, what is interesting is that 22 of these chromosomes, or I'm sorry, 22 pairs of these chromosomes, or a total of 44 chromosomes, will have, will be called the autosomal chromosomes, or autosomes, okay? These are the autosomes chromosomes. And these are chromosomes that carry a lot of our traits in them. However, we have just 2 here that are going to be the last 2 for the total of 46, which are the X and the Y chromosomes, and these are called the sex chromosomes. Okay, so we have a total of 46 of these chromosomes that all carry different traits. However, only some traits will be passed on from parents to offspring via the X and the Y. So we need to know how these are going to pass on from parents to offspring. So just to have a little bit of more info, make sure that you write this down on your paper. Sex-linked inheritance is when genes for any specific trait are located on the sex chromosomes, in the X chromosome or in the Y chromosome. Something interesting to know is that actually most traits are carried on the X chromosome. So the sex-linked traits that we're going to be talking about, most of them will be carried on that X chromosomes, while some, very few of them, will be carried on the Y chromosome. You always have to look out for that. The problems that we're going to do, they should specify whether the genetic condition or the trait is carried on the X or the Y. So you have to be on the lookout for that. They should tell you on the problem where it is carried on. So one very good example of that is actually color blindness. So color blindness is a condition where people cannot really depict the difference in the red color and green color, and rather they see something that looks like this on this side of the image. They see everything very kind of like mm, greenish, light greenish, and yellowish and orange, rather than something that looks like this, where you have all those green bright colors and red and orange colors. So this is one condition that is actually carried on the X chromosome. And you can actually detect this by taking very simple tests, like looking at this circle here, and you can actually have to look for a specific number. So you see number 42 on this picture. Obviously, you're not going to see number 42 because this is what a colorblind person will normally look at. However, someone who is not colorblind will look at this picture and will be able to depict that number 42 right here. And then there's that 2 there. Okay? So obviously, if you're colorblind, you can't really see that number 42. It looks more like this image that I'm showing you here, but that just means that you have the color blindness. There's another example. You can see what number do you see here? Number 74. And this is another one, a little harder, but you can actually see that number 7 here. So I hope this test was enough for you to try to figure out, whoops, kind of went all over the place there. Hope this test was enough for you to figure out whether you are colorblind or not. Now let me just work an example together, okay? So this is going to be the type of problems that you have to be able to answer. It says here that a woman who is a carrier for color blindness, and these are the links, the alleles that we're going to assign her, the genotype that we're going to assign her, marries a non-colorblind male, and these right here are the alleles that we're going to assign him. So we have to figure out what are going to be the chances of having a male, a boy, that is going to be colorblind, and what are the chances of having a girl that is also colorblind. So something that I need to make sure that I emphasize here is that notice that since it's a woman, we're talking about a woman, you want to have X and X, okay? Now, since she's a carrier, that means that she is a heterozygous. And so if she's a heterozygous, she's going to have a big H for color blindness and a lowercase h if you just want to use that letter. Okay, we could use any letter, but we just decided to use the letter H. So big H, little h, one on one chromosome and the other one on the other chromosome. You never put them together. You always put them on separate chromosomes. So you want big H and little h since she is a heterozygous. Now, if I told you that she had color blindness, remember that for her to have color blindness, okay, and I'm going to write that on this side, color blindness, she has to have 2 lowercase h's. So that's the only way that she's going to have colorblind, because color blindness is actually a recessive trait. And I know I didn't specify here, but it actually is. So it has to be little h, okay? So what if we have a boy that is colorblind? She marries a man that is not colorblind, but what if we had a boy that is colorblind? Well, remember that a boy is X and Y, but since it is carried on the X chromosome only, you want to put a little h here. Now the Y chromosome, you just leave it alone because we're not really emphasizing anything on the Y chromosome. We're just talking about the X chromosome. So that's what color blindness will look like on a woman and on a man. Anything different means that this person is not going to be colorblind. So we have this carrier, we put her on the side here, and then we have the man, X big H, who is not a colorblind man, and the Y, and we cross them, and we're going to get, we do the same process that we've done. We're going to get this for the offspring. Then we have X big H and Y. Then here we have X big H, X little h, and X little h and Y. So what are the chances that this couple will have a colorblind male, a colorblind boy? So if you look at this square here, these two right here are females. So we're actually looking for boys. So these two are the boys. That means that 1.5 chance of having a boy that is going to be colorblind. Okay, again, to be colorblind, you have to have that lower age. So there's a 1/2% chance of having a boy that is colorblind. And for a girl, well, you have literally 0% chance of having a girl who is colorblind. The only thing that you could have is a girl who is a carrier like the mom is. So these two here, you're going to have 0% chance of having a girl that will be colorblind. And so this is how you will approach this specific type of problems, okay? Now, just a little more info here. There's other examples of sex-linked traits because obviously color blindness is just one example, but baldness or male baldness is another example. Hemophilia, who is a really, really rare genetic condition. Muscular dystrophy, and ocular albinism, which looks like this person right here. Those are all different traits that are carried on the X and the Y chromosome. For the most part, these right here are actually all carried on the X chromosome. The Y very few times carry some of these traits. So just an exit ticket to wrap all this up together. It says that a woman happened to be a carrier for sex-linked genetic condition of hemophilia. So if this woman is a carrier for hemophilia, we're going to assign her a letter. So since we're using hemophilia, let's just use the letter H. And we're talking about a woman, so she's X and X. And we're going to make sure that she's a carrier. So to be a carrier, she has to be heterozygous. So big H, little h for hemophilia. Now, hemophilia is carried on the X chromosome, and that's information that you want to make sure that you look for on any question that is sex-linked related. You want to make sure that they tell you that it's X chromosome or Y chromosome. Now, it says that she marries a man without hemophilia, and she wants to know what are the chances of having a daughter or a son with hemophilia. Just like the last example we did, the man that she married, we know that the man is going to be X and Y, and this man doesn't have hemophilia, so he has to have a capital H in here. So I want you to make sure that you finish that cross on your paper and that you write down the percentages for either having a boy or a male with hemophilia. So what are the percentages of these? And having a female with hemophilia. So make sure that you answer those questions on your paper and you provide an answer on the paper. All right, I'm going to go ahead and stop on this problem right here, guys. I hope that you found this interesting and helpful. And don't forget to write a summary for your Cornell notes, and I'll see you on the next video.